draw 50 X values from between 3 and 12 from uniform random distribution. We'll draw 50 Z values from standard normal distribution. We'll draw to compute 50 W values as 4 minus 3 times X plus 9Z from the Z and X we have in A and B, and then 50 E values from standard normal distribution. And then we'll compute Y values equal to 2 plus 3 times X plus 4 times W plus 5E. We are going to do two things. One, that we are going to regress Y on X, whereas Y is generated from X and W, whereas in F part we are going to regress Y on X and W. So in first we are going to ignore W, in second we are going to include W as well. Then we'll repeat this process 1000 times. So we'll have B slope when we'll regress Y on X, and we'll have BB when we'll regress Y on X and W. So when we ignore W, what will be slope value of X? When we include W, what will be slope value of X? And the first one we are saying B, second one we are saying BB, and we'll replicate this process 1000 times. And then we'll make a distribution of those 1000 B and 1000 BB. That will be your sampling distribution of slope coefficient. Let's go. Let's say this is B, this is B naught. This one's Excel. In Excel we have this is BB, and here we have BB. In Excel basically you have first intercept and then the coefficients move in this way. So here we are going to say linest equal to, okay, first of all I just press Control tilde to show you the formulas. So we have drawn random numbers in this way. You can see here we have drawn normal random numbers between 3 and 12, and then we have calculated W, then we have DE as standard normal, and then we have calculated Y. So just I'm going to press again Control tilde. So I'm going to regress Y on X by ignoring W, because Y is generated by including W. So Y on X, this is Y, and this is regressed on X values. We are not including W here. So if you have array, so Control Shift Enter, you have slope value equal to minus 8.09 and intercept value this one. Now we are going to include W as well. So linest, LENIST, linest tab Y E1 to E50, 1 E2 to E51, and here we have Control Shift upward arrow. Okay, so you have slope, sorry, this is not BB. This is your BB. This is your BB, this is your B. So we are going to calculate this B and BB 1000 times. And to do that, I'm going to do a simulation. So let's equal to this equal to B when Y is regressed on X, and this is equal to BB when Y is regressed on X and W. So we are going to generate it 1000 times. Let's see, 1000 times. Okay, let's do it 1000 times. We are generating 1000, we are generating 50 values, and every time we are going to repeat it, and we have repeated this process 1000 times. Data, what if analysis, data table, and keep first blank and then give this cell reference. You'll have 1000 values of the slope and all this. So you see, every time we take a sample of size 50, we regress Y on X and W, we get this BB. Again BB, again BB. We are doing this process 1000 times. And instead of replicating it time and again, I am going to copy paste and Alt ESV paste special so that these values don't change. And now we have these 1000 values. Take the average of this BB, AVREG H1 H1000. So this will be very close to the actual value. Oops, something wrong. Average H1000. So average deviation, basically I want to take average, 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 that's very close to 2.99, that is 3 coefficient of x. Now I am going to take average of this one when your w variable was not included. So you see, you will have high bias. Instead of 3, you are getting -9. And similarly, when you take variance of b, variance of b, it will be very close to 0, because you have estimators with very less variation, 0.13, right, and its square root. So you'll have variance very small, and here you are given compute the value, their variances, and which variance you assume will be equal to 0. That is also explained in my previous video on understanding sampling distribution of estimator. Now we'll make the distribution of this one. In practice, you get either this slope or this or this or this or this or this or this. You have only one sample. But to demonstrate in statistical theory, basically we assume that that estimator has been from, if it has some distribution like this one, from which you have that one slope coefficient like 3.20. So it's different than 3, but in general you'll have the single sample and you'll have a single estimate. And but this has some sort of distribution. What is that distribution? That is this one, which I am going to demonstrate in front of you. Data analysis. Just go to histogram. Okay, histogram H1 H1000, and I am going to T3. Okay, fine, that's okay. Right, so you see, you will have a frequency, you have class intervals up to 1.87, 1.87 to 1.94, 1.94 to 2.02, and now you have this distribution, and this is called sampling distribution of an estimator. Beta hat basically follows this distribution. Basically you get one beta, but you assume that it has some distribution like that, out of which you have picked only one beta, one hat. I hope you have got little understanding of sampling distribution of a slope coefficient. Thank you for watching. Take care. All the best.